All right, so my name is Preston Black, and this is my third observation for National University. And today we're going to be going over 8MF.2, which is the introduction to functions. So we're going to be looking for inputs and outputs and the difference between linear and non-linear functions. Okay, so this is my small group that I'll be working with. Everyone wave to the camera. All right, thank you. And right now you guys have your whiteboards in front of you. What I would like you to do is I want you to write down what variable do we give the input, what variable do we give the output, and then what is a linear equation. Okay, so go ahead and write that down on your whiteboard, and then I will ask you all to share out at the same time. Okay, so I'll give you about a minute to write that down, and then we will share out. So we use these whiteboards each day. It's one of the areas that the kids, they like using the whiteboards. They like showing off their work. And it's a way for them to all show me at the same time. So I can see exactly who has understood the information prior to today's lesson, and then who may I have to scaffold back for and may not have gotten all of the information yesterday because they were absent or just because they didn't comprehend the lesson. So the use of the whiteboards is big, especially with math and with my group. It works pretty well. All right, about 20 more seconds. Also today I will be using two computers. My school computer, I lag really badly with Zoom, but it's a touchpad, and so the work that we'll be doing is on there. So that's why you see there's two of me here. It's my other computer logged in, and we will go ahead and switch over to that here in a second. Okay, so you should have the information written down on your whiteboard. Since it is close to the holidays, let's go ahead and I'll sing a little song and then you'll hold up your whiteboards, okay? So once I stop singing, go ahead and hold up your whiteboards, okay? Jingle bell, jingle bell, jingle bell rock. There we go. Good job. Hold it a little bit closer. Good. Gabriel, a little bit higher. A little bit higher. Good. X equals the input. Y equals the output. Linear function is a function with a straight line. Good. Good. Very good, guys. Good. All right. Go ahead and erase your whiteboards. Go ahead and erase your whiteboards. Go ahead and erase it. And what I would like you to do is go ahead and turn to page 353. No, 352. Sorry, 352 in your ready textbook. All right, so now what I'm going to do is I'm going to switch over to the other computer and share my screen, and then we're just going to go over some of the problems on there from their actual textbook. As you can see, it's definitely a lot laggier. All right, can you guys hear me on this computer? Yep. All right, thank you. Are we on page 353? Or 352, sorry, 352. Hit thumbs up, 352. All right, I'm gonna share my screen for just 1 second. Can you guys see my screen? Thumbs up. All right, perfect. So we are looking at problem number 3. Problem number 3. Okay. Philip, can you read question 3 out loud for me, please?
Use the rule to complete the table. Input, do I say the input?
Yeah, go ahead.
Okay. Use the rule to complete the table. Input is X and the number of tickets that cost $9 each, and the output is Y, the total cost.
Right. Good job, Philip. Thank you. So we're looking at the number of tickets that cost $9, and then the output is total cost, right? Super duper informational, right? We're able to read exactly what the table is showing us, right? Each ticket costs $9, and then the output is the total cost. So let's go ahead and look at the table. Okay, let's look at the table. And we notice that there already is an input and an output given to us. What does the input and the output mean here? What are we looking for? We see a 1 and we see $9. What is the correlation between the two? Abby, what is the correlation between the two? What does, if we were just to look at this and not realize what it meant or what it said, how could we look at the table and see what they're trying to tell us? Abby? Can somebody help Abby out? Can you guys hear me?
We can go by 9, so you go 9, so the next number would be 10, maybe.
Okay, so good, Margarita. Thank you for hopping in. But if we just look at this, imagine this isn't here. Imagine these are not here, right? All we are given is this information here. What do we notice? We notice that one ticket costs how much?
$9.
$9. Good. So we know that our input is 1 and our output is $9. So for every one ticket, it's going to cost $9. Right? So I'm going to go ahead and give you a minute or so to fill out the rest of the table. Right? We know that one ticket is $9. So then what is 2 tickets? What is 3 tickets? And what does 10 tickets cost? Okay, so I'll give you a minute and a half. Go ahead and fill out the table, and then we are going to share out our answers. Some of these learners are definitely more shy on the computer. So trying to get a response out of them, usually in small group is a little bit easier, but getting closer to the winter break that we have coming up in tomorrow, I think some of them are definitely already there. All right, so your table should be filled out. Table should be filled out. Would anyone like to share out how much 2 tickets would cost? How much 2 tickets would cost?
I got 18.
18. And Margarita, how did you get 18?
Well, I did 9 plus 9, which is 18, and I did that for all of them.
Okay, good. So you did good. So you did 9 plus 9. And why did you do 9 plus 9? Why didn't you do 9 plus 9 plus 9 plus 9? Why did you only do 2 of them?
Because if you look at your X, you know that the top is 2, so that means you have to do it twice.
Very good, right? We're not looking for 3, 4, 5 tickets in this problem. We're only looking for 2 tickets, right? So we know 9 plus 9 equals 18, or 9 times 2 equals 18, right? So if we do 9 plus 9 equals 18 for 2, what about for 3? We can do 9 plus 9 plus 9, or 9 times 3. And what is 9 times 3?
27.
Very good. Thank you, Gabriel. 27. Okay. And then what do we notice? Right? We go from 1, 2, 3. And then what would you normally think the next number would be in the table? Right? We see how many boxes? 1, 2, 3, or 4 boxes. Right? What number do you think would come next? It would have been what? Hold it up on your hand. Hold it up on your hand. 4, right? You would think that. And I guarantee some of you or some of the other learners would have rushed through this and just would have expected that to be 4, right? So you need to slow down, take your time, look over the entire question before you put down your answer. So if we follow the same method that we did to solve for 2 and 3, how do we solve for 10? What do we have to do? 10 times what?
Multiply 9 by 10.
Why are we multiplying 9 by 10, Gabriel?
Then you would get 90.
But why? Why are we multiplying 10 times 9?
Because you're buying 10 tickets and the cost is 9, so 9 times 10.
Very good. Very good, Gabriel. So it's 90, right? So is there a pattern to this? Is there a pattern to this problem? Margarita, what is the pattern? It's so each ticket is going up by $9. So for every ticket, no matter how many you buy, right? We see that here from 1 to 2 to 3 to 10, right? Each ticket is still $9. Okay? So explain why this rule is a function. Earlier we looked at some that were not functions, right? What were some of the problems, or what were some of the reasons for a table to not be a function? What were some of the things that we saw?
We saw two numbers.
Two numbers where?
So for it not to be a linear function, we saw two numbers on the output, and one of them was negative, one was positive.
There you go. Boom. Thank you, Margarita. Right? We saw a table like this, right? Where we had, it was 1, 2, 3, and 4, right? But we had a -1 and a 1, right? In the output. Remember, what does a function have to have in order for it to be a function? You need to have what, Philip?
It has to have an input and an output.
Can it have one input and 3 outputs?
No, it has to have one input and they all have to have one output.
Very good. So they all have to have one input and one output. Does this table have one input and one output? Thumbs up if it does, thumbs down if it doesn't. Now, does this table here? Does it have one input and one output? It does, right? The input is 1. The output is $9. Right? It wasn't 9 and -9. Or it wasn't 9 and 8. Right? It was $9. For 2 tickets, it's always going to be $18. For 3 tickets, it's always going to be $27. Right? Good. So we were able to find the cost of the tickets. Now, we're going to look at another table. So use the rule to complete a table, right? We talked about the rule of the function. It needs to have one input and one output. Okay, now we're really going to have to think about this table. Okay, so Philip, you read the last one. Can you read question 4, please?
Use the rule to complete the table. Input is x and an angle, and the output is y, and the angle is supplementary to x.
Okay, so big words, right? We have not seen a table like this before. This is the first time that we are seeing it. What are some things that you notice? Okay, Philip, I want you to type to Gabriel. Okay, Margarita, type to Abby. And Cassandra, type to me. Okay, those are your partners for this. So just type some things that you notice about it. What do you notice about this table? What is different about this table than some of the other ones that we have looked at? Right? Differences right here. We're looking at table for question 4.
I noticed that
Oh, no. Cassandra, I like you coming off mute, but just go ahead and type it to me. Just go ahead and type it to me. Okay, good job. Okay. So because I am using 2 computers, the chat box is also on the other computer. So I'm looking at the other computer for the chat and then reading the responses, and then I'll respond on here. Good. Okay. Philip, what was one thing that you noticed that was different?
the sum of both of the angles, or 180.
Okay. So the sum was equal to 180. Okay. Cassandra, go ahead and share out what you shared. Sorry.
That they're using degrees instead of regular numbers.
All right, so we're using degrees. We're not using dollars, right? We're not using just 1, 2, 3, or 4. We're using 10 degrees, not just 10 or $10, right? So that is different. Margarita, what was one thing that you noticed that was different?
That they're giving us bigger numbers, and that they're also
They're bigger numbers than what?
getting us angles. That's what me and my partner.
Okay, so bigger numbers and angles. Very good, right? Very good observations. There we go. Mute Philip. So we're using angles, we're using degrees, we're using bigger numbers. The sum is adding up to 180. Okay. So let's go ahead and look at the first input that they give us. So that what is the input to this first box? Right? What is the input? What is the input for the first box? Gabriel, what is the input for the first box?
10
10 what?
degrees.
10 degrees. And then what is the output?
170 degrees.
170 degrees. Okay. So let's look at the next one. The next one, we have 26 degrees and 154 degrees. What do we notice about the input? How many more degrees did the input go up? To go from 10 to 26. 16, right? So we added 16. We added 16 degrees. Now, let's look at the output. Whoa, the output's not the same as it was in the first box. How much did that go down?
16.
16 degrees. So what do we notice? What is something that we notice?
The input goes up 16 degrees and the output goes down 16 degrees.
Right. So the input is going up at the same amount as the output is decreasing. Right? So we know that these have gone up and down 16 degrees. What about the next one? What about the next one? We know that the input is different, right? It goes up. How much does it go up? What is 45 minus 26? 2, 3. 15 minus 6 is 9. 3 minus 2 is 1. So it's gone up 19 degrees. If we follow the pattern, how much should the output go down? How much should the output go down? 19 degrees. Good. So then what is 154 minus 19? 14 minus 9 is 5. So 135 degrees. Okay, so go ahead and fill out the rest of the table. Go ahead and fill it out for 90 degrees, for 112 degrees, and then for 175. Okay, I'll give you guys 2 minutes, and then we'll come back and we'll share out our answers. So we have not seen any type of input and output like this so far, whether it's been in whole group instruction or small group instruction. So they did a very good job of explaining the differences and how Philip right away knew that the sum of both the input and the output would equal 180 degrees. Fist of 5. How many more minutes do you need? 0, 0, 0. Okay, perfect. So our next block, our next input is 90 degrees. What is our output?
90 degrees.
90 degrees. Right? And how do you know that, Philip?
The sum is always 180.
Okay. If you didn't know the sum was 180, what could you do by looking at the table and seeing the pattern that is forming? You're on mute.
I didn't think ahead.
What was that?
I didn't think that far ahead. I just knew supplementary meant 180 degrees.
Okay. So we looked at the first block and it went from 10 to 26, right? So we knew that there was a 16 degree difference in the inputs. Then we went 26 to 45 and we find out there's a 19 degree difference. What's the difference between 45 and 90? What is 90 minus 45? Or 45, right? So if we know there's a 45 degree difference in the input, we know there's going to be a 45 degree difference in the output, right? So then if you didn't know what supplementary angle meant, you could just do 135 minus 45. It gives you 0, 0, 90. All right, Gabriel, what was the next output for 112 degrees? Was it 67 or was it 68? 68, right? Because you went up 22 degrees from here to here. So you must go down 22 degrees from here to here. So 90 minus 68, 8, 2, 2. Yep. So it adds up. And then what about the last one? Everybody should have gotten this one. What is, hold up on your hand. What is the output for 175 degrees? 5. High five. I'm giving you guys all a virtual high five right now. All right, so it's 5 degrees, right? So now let's look at this. Is this a function? Is this a function? What do you think? Thumbs up if it is, thumbs down if it isn't. Thumbs up. We got 1 thumbs up. 2 thumbs up. 3 thumbs up. Cassandra, what do you think? Thumb up, thumb down, thumb up. Gabriel? Oh, we lost Gabriel. Okay. It is. And why is it? Because why? What is the rule? Margarita, what is the rule? You are muted. What makes this a function? Because it only has what?
As a straight line, if it's not.
So that would be a linear function. But is it just a function? Is this a function? What do we need in order for it to be a function? We need what, Philip?
An input and 1 output.
1 input and 1 output. And in this table, we had 1 input and 1 output for each. For each input, we only had 1 output. Okay? So while you guys are working on your independent work, I have a Padlet for you to fill out. So give me 1 second. I'm going to switch back computers. All right. Let's turn this off. All right, there we go. So let me get the Padlet. So you're just reflecting on the work that we did today. So what I want you to do is while you are filling it out, think about the problem that we just worked on. Okay, think about the degree problem whenever you were filling it out, because you're going to be asked to put the inputs and the outputs. Okay? All right. So I'll give you guys like 5 minutes. Go ahead and fill this out, and then you can go ahead and work on your independent work. Okay? Perfect. Great job today. And thank you for being part of my video. All right, go ahead and wave goodbye.